All right, guys. Week 3 commences. Okay, last week we were dealing with, right at the end of the week, coming up with this circular equation formula. Okay, remember sometimes we call it the standard form of the circular equation. Sometimes it's called the general form of the circular equation. But it just acts as a formula. Okay, so if the center is at HK, and remember we normally use HK for the coordinates of the center of a circle, although that's not a law. You could use AB, RS, whatever you want to use. Doesn't make any difference. So it's going to be x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals the radius squared. Okay. All right, now the radius obviously here, okay, would be the square root of radius squared. Okay, so you got to keep that in mind. Okay, if you're asked for the radius, okay, then you would have to take whatever this number is right here, this constant, and take the square root to get the radius, because that's always radius squared. Okay, so we're going to use this guy today to get through some basic ones right here. Okay, so they might give you a graph of the circle, some sort of diagram, and they want you to write the equation of the circle. Okay, so I need the coordinates of the center, okay, and I need the radius. Okay, so let's see. Right here, if I trust my eyes, it looks like the coordinates of the center are going to be -3, -2. Okay, so that center is at -3, -2. Okay, so that means that my HK is -3, -2. Okay, now I need the radius. Okay, so again, we got to trust our eyes. So I would count vertically to the right, vertically to the left, vertically up, and vertically down, and make sure we get the same thing. So it looks like I get 1, 2, 3 going to the right, 1, 2, 3 going to the left, 1, 2, 3 going up, and 1, 2, 3 going down. So if we trust our eyes, it looks like the radius is 3. Okay, so we go to our general form or our standard form, okay, our formula. So we have x minus h squared plus y minus k squared equals r squared. And then we substitute in. Okay, so my h is the x coordinate of the center, so I get x minus a -3 squared plus my k is the y coordinate of the center, so I'm going to get y minus a -2 squared equals the radius squared, and the radius is 3 squared. Okay, and then from here on out, it's just a matter of just simplifying some things. Of course, we know we never like this minus a negative, so we would make that positive. Okay, so that's x plus 3 squared plus, do the same thing here. We don't want y minus a -2, so we write it as y plus 2. Y plus 2 squared equals, and then 3 squared is 9. And so you have the standard form or general form, okay, of the equation of this circle in the diagram. Okay, one in the books. Okay, second one. Same sort of situation. Okay, we are looking for the equation, so I need the center and I need the radius. So let's see. It looks like my center is at 2, 0. Okay, so my HK is 2, 0. Okay, then again, I'm going to count due east, due west, due north, due south to see what the radius is. So let's see, I go 1, 2, 3, 4. 1, 2, 3, 4. So it looks like 4 to the right and 4 up. Oh, I'm sorry, 4 to the right and 4 to the left. 1, 2, 3, 4, and 1, 2, 3, 4. So 4 up and 4 down. So it certainly looks like our radius is 4. Okay, so let's see, we go to our formula, x minus h squared plus y minus k squared equals r squared, and we substitute in. Okay, so x minus h is the x coordinate of the center, so that's 2 squared plus y minus K is the y coordinate of the center, so that'd be 0 squared equals the radius squared, 4 squared. And then we just simplify. Okay, so x minus 2 squared plus. Now, y minus 0, okay, we could actually drop the minus 0, okay, and just write this as y squared, okay? So that is usually how you would see it in any high school or college level mathematics book, okay? They're not going to leave it as y minus 0. They're going to drop that 0 off, okay? Equals 4 squared is 16, okay? And so, again, we have our general form or standard form of our equation for the circle in this diagram. Okay. One more. Let's see. Okay, well, clearly it appears that our center is at the origin. So 0, 0. Okay, so it looks like our HK is just 0, 0. Okay, let's figure out what our radius is. So it looks like I go 5 to the right, 1, 2, 3, 4, 5. Okay, 5 to the left, 1, 2, 3, 4, 5, good. 5 up, 1, 2, 3, 4, 5, and 5 down. 1, 2, 3, 4, 5. So it looks like our radius is 5. Okay, so we go to our formula, x minus h squared plus y minus k squared equals the radius squared. Okay, and look at our h is 0 and our k is 0. So we get x minus 0 squared plus y minus 0 squared equals our radius squared, which is 5 squared. And just like the last problem that we did, we would normally drop off these zeros, okay? Technically, you could leave it as x minus 0 and y minus 0, okay? Numerically, you'd be correct, but it's customary to drop those off. So we would just write this x minus 0 squared as x squared, and we would write this y minus 0 squared as y squared, and obviously 5 squared is 25. Okay, so you have your general form or your standard form of the equation of that circle in the diagram. Okay, so we're good there. All right, those are the easiest ones, okay, that you usually see. Okay, now this guy doesn't give you a diagram. Okay, so you know me, I'm probably going to make myself a little diagram. Okay, so I have a circle, and I know, oh boy, that's a bad looking circle. And I know its center is at -5, -1. Okay, so I know my HK is at -5, -1. Okay, now it says this circle passes through the point 0, 7. So somewhere on this circle, okay, we have this point at 0, 7. Okay, now the problem is I don't know what the radius is. Okay, that's my unknown. Okay, but I know the radius is a segment that connects the center with any point on the circle. And that radius is going to be the same no matter where I look in the circle. So I know this radius is right here. So all I've got to do is find the length of that segment, and I'll have the radius. Okay, so when we want segment length, we just use the distance formula. Okay, so our radius ends up being the distance between these 2 points, okay, using our distance formula. So that would be delta x squared plus delta y squared, and then take the square root. Okay, so let's see, our radius, square root of, let's see, delta x, so I could go -5 minus 0. I don't need that. Why did I put that comma in there? -5 minus 0 squared plus delta y. Notice I could go 7 minus a -1 squared. Okay, so let's see. Our radius, square root of, well, let's see. This would be -5 squared, which is 25. This would be 8, so 8 squared is 64. Okay, so my radius is the square root of 89. Okay, so let's see. Now I know what my radius is, so I can go to my formula. X minus h squared plus y minus k squared equals the radius squared. Okay, so let's see. X minus h is the x coordinate of the center, so that's -5, plus y minus k is the y coordinate of the center, so that's a -1, equals the radius, which is radical 89, squared. And then we just simplify. Okay, again, we don't like these double negatives, so x minus a -5 right here would just be x plus 5. Once again, same thing here, y minus a -1, that would just be y plus 1. And right here, anytime we square a square root, we get the radicand, so that's just 89. Okay, and you have your general form or standard form of the equation of a circle with this center that passes through that point. Okay, and so this is a little bit more difficult than the first couple we did because they don't give you the radius. Okay, you've got to figure out what the radius is. Okay, that'll wrap it up. Short video today, and there will be more posted this week. Don't forget that the quiz is due tonight from last week, so get that turned in if you haven't already done that. And be safe out there, and I miss all of you.